Maclaurin. All right, here at question number 6 for the 2018 AP exam. Now, this was a really good series question. I think you should be able to get them pretty easily. All right, so they give us the Maclaurin series. Now, don't forget for Maclaurin, whoops, let me switch to a pen real fast. For Maclaurin, don't forget they're telling us that the center is at 0. So this will approximate anything near 0. That's what Maclaurin is saying right there. And they're telling us that this right here is the natural log of 1 plus x. Now, we know this is a series because of the plus dot, dot, dot. In a polynomial, we terminate it. All right, so they tell us that this will converge for basically anything near 0. On its interval of convergence, this series converges to the natural log of 1 plus x. And let f be the function defined by this right here. So it's x times the natural log of 1 plus x over 3. Now, well, what they're asking us to do here is they're asking us to expand on a series. In other words, just rewrite something. This is pretty easy to do. The first one, it says, write the first 4 non-zero terms of the Maclaurin series for f. Now, this is not on the 2020, but I think it's an interesting question to be able to do. So I'm going to put this in here. So we know that the natural log of 1 plus x is x minus x squared over 2 plus x cubed over 3 minus x to the 4th over 4, plus, of course, a dot, dot, dot. The first thing we're going to do is we're going to replace this inside x, the natural log of 1 plus x over 3. All that tells me is everywhere there's an x, I put in an x over 3. So the first one we get x over 3 minus this becomes x squared, x over 3 squared, or x squared over 3 squared. Don't forget times that 2. Plus this becomes x cubed, or x over 3 cubed over 3. So we get x cubed over 3 cubed. Don't forget that 3. And I keep going. This becomes x to the 4th over 3 to the 4th times 4 plus dot, dot, dot. And in the last one, they're just telling me now multiply all of that by x. Again, this is not on the 2020, but it's a good one to know, especially for those of you going to college next year and so on and so forth. So this becomes x squared over 3 minus x cubed. I'm just multiplying everything here by x over 3 squared times 2 plus x to the 4th over 3 cubed times 3 minus x to the 5th over, what's that, 3 to the 4th times 4 plus dot, dot, dot. Plus, now I'm going to give the general term here. Again, this is my polynomial approximation. This is saying that it's a series that it goes on forever right there. So what I'm going to do is I'm going to go ahead and give the general term. And the general term here is not so bad. It is alternating, so it's going to become -1. And because it starts off positive, I go n plus 1. Looking up here, this becomes, oh look, when n is 1, this is a 2, so I get x to the n plus 1 on bottom. I'm going to get 3, 2, sorry, 1, 2, 3. So you get, there's a times of 1 here. 1, 2, 3. So I'm going to get this n. And now I'm going to do this 3, and this becomes 3 to the, of course, n as well. And you go plus dot, 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 that at the end. Now, how much would this be worth? You would get plus 1 for the first 4 terms, and you would get plus 1 for that. Now, again, that's not on the 2020, but it's a good one to know how to do. What is on the 2020 is how I change part B. Part B actually has to determine the interval of convergence. That is not on the 2020, so we're not going to worry about that for this test. Instead, we're going to determine if this series converges. And that is on the AP exam for us. So if we look at our general term from part A, as n goes from 1 to infinity, I want to know if this series here converges. And we get this -1 to the n plus 1 times x to the n plus 1 over n times 3 to the n. And what test am I going to use here? Now, remember, this is converging for anything. Let's say for x equals 1. So we'll just get rid of that. We'll just make that a 1 right there. Okay. Now that's not on here, but we have to actually kind of do that for this problem, see if it converges. The x is actually for interval of convergence, which I'll show you on a later video, which is not on the 2020. I just want to know if this series converges right here. And if you notice, this is an alternating series. And if I take the limit as n goes to infinity of my term here, this becomes 0. So we can say the series alternates, decreases in magnitude, and the limit equals 0. Therefore, the series converges by alternating series test. And that'll be worth about 2 points. That is on the AP. The other one I wanted to make sure you know the ratio test. I have a good feeling that's going to be on the AP exam this year. All right. So next, they said that P of 4 equal X. P of 4. So they're telling us a fourth degree Taylor polynomial about X equals 0. Using the alternating series error bound, find the upper bound for this. In other words, they're asking us what's the most we can be off by. So if we're looking at, remember the alternating series error says that the most the fourth term could be off by is less than or equal to the next term, the fifth term, right here. So we can say, now let's go and get the next term. Well, what do we get the next term for? Well, we know here, coming back, we can get our fifth term right here. There's our fifth, not our fifth term, our fifth degree polynomial is x to the fifth over 3 to the fourth times 4. And they're asking us to approximate x at 2. So my fifth term, remember, was this negative, and it's going to be magnitude, so magnitude, negative x to the fifth over 3 to the fourth times 4. And if I let x equal 2, and if I plug that in, I'm going to get negative, magnitude, negative 32 over 4 times whatever 3 to the fourth is. They don't expect you to know that yet. And that's going to equal 32 over 4 times 3 to the fourth. And that's what we can say. Because, and you should write this out, because the series alternates, decreases in magnitude, and the limit equals 0 by the alternating series remainder, or error. They use error, so we should use error too. The upper bound, and that's what we should say, the upper bound, use the same phrasing they did. Upper bound is 32 over 4 times 3 to the fourth. Now, what they're really saying is that this is the most we can be off by. The most we can be off. All right. So there we go. That's a series question. Hope you guys enjoyed it. And this is worth 1 point here, and we'll just 1 point for justification. And I'll see you guys later. Thank you, guys.